Hi, how are you guys doing? Oh, guys, I missed you on the last lecture. Anyways, I have decided to do this lecture for you. As the saying goes, last days are dangerous. But I should have had this lecture with you, but I decided to put it in a recording mode so that you can always refer to it. All right. Okay, so as I spoke to you the last time, I said our last lecture would be on truth trees. Okay, having done truth tables, which is quite mechanical, I know you at least have some understanding about how the truth tables are constructed. But in this lecture, we'll be looking at how graphical we can go with truth trees. What kind of steps can we take to solving problems that are related to truth trees, right? So, um, let me see here. Let me bring out my laser. Okay. Okay. So, uh, this is a typical example of a truth tree, but we want to start off with mathematical equation so you can appreciate what I really want to carry across to you. So as you can see here, we have a very lengthy equation, all right? Don't let the equation scare you. All you just need to look out for will be the connective. What is connecting this equation to the other, all right? So that is what is going to bring about the split, or in other words, going to bring about the decomposition. So there are some terms you need to look at. Term like decomposition, what does it mean? It means you are simplifying, or in other words, you are breaking down to its barest minimum. That's what we call decomposition. Okay, and so with this, for instance, let me change this to 10. So you realize that at the top of the food chain, or in other words, at the top of this tree, so this is the tree, this is the root of the tree, this portion is the root of the tree, okay? So you can see that in it are some listings. When I say listings, saying you are breaking them down, okay, you are listing out the literals. In other words, trying to break it down to its barest minimum. So you can see that this equation carefully has two equations put together. There's looking at this bracket and this bracket. This makes it one whole equation. Then looking at this, it makes this also a whole separated equation. However, these two equations are connected by this minus. So we call this what? A connective, right? A connective. Okay, so as you can see, the breakdown has started. So we break it down further. We carry this block of equation down to the next stage, all right? So at this stage, they are all equal. That is why at each level, this is one level, another level, another level to the last level. So what we are trying to say is that at this level, they are all the same. But the breakdown, this portion of the equation is equal to this portion of the equation, right? So that means that this is still compounded. We need to further break it down, all right? So you can see that when you look at this forms one portion of the equation. This also forms another portion of the equation. Now this becomes what? The connective. So we break it down. So you see that that is why we have the standing alone here. Now this becomes a literal. literal, L, literal. That means that it cannot further be broken down, right? So at this point, we have ended the life for the 5 here. Now, when we go to the other side of the equation, now this, okay, still can be broken down because we still can identify a connective in there, right? So we will break it down further. Now, at this point, we have a literal, which means that it can't further be broken down. These two can't further be broken down. So once you understand the concept on this side of the equation, then you would also be able to apply it in here. So this, okay, at this point, we have two separate equations now connected by a literal. So we break it down, okay? Break it down till we get to the literal. So at this point, it can't further be broken down. At this point, it can't further be broken down. At this point, it can't further be broken down. At this point, it can't further be broken down. All right. So having done this, then it means that we have successfully decomposed this equation. All right. We have further broken down this equation. Now, this is just by way of introducing the course to you. All right, this is what it takes to understand the concept of truth trees. All right, good. So having done this, then we can continue. Okay, let me erase all. Okay, so we move on to the next stage. Now I want to understand some theory behind the truth trees. Just like truth table, a truth tree is a decision procedure. All right. It's a decision procedure. All right. It's a decision procedure. What is a decision procedure? Meaning that at every junction, you would need to decide as to which path to take. All right. At any junction, you need to decide as to which path to take. And it is more than a mechanical procedure, as in the case of the truth table. The truth tree can be managed, and it is more graphical. That's what we mean, can be managed. Every tree, when planted, what happens if unmanaged, can grow in so many directions, right? Assuming that there was a heavy wind, all right, the tree can tilt and it will grow in that direction, all right? So if it's not managed, it can go bad, all right? So we are saying that trees can be managed. And the method of truth trees is also known as the semantic decomposition trees, all right? Or a semantic tableau. Semantic tableau. All right. So it is semantic because it is semantic because in the sense that it is formulated in terms of true values. So we realize that when we did our truth table, there were certain values that were gotten, either true or false, or either 0 or 1, right? So those values, we are saying that in the case of semantic, it presents a sense that at least you can obtain some truth values from them. And it's also algorithmic, like algor. My tongue is becoming too short. It's an algorithm, so it follows an algorithmic kind of procedure. All right, in the sense that its steps can be carried out by a computer. All right, so in as much as it follows a kind of algorithm, it gives you or presents you a step-by-step approach to solving the problem. Now, this is a typical example of what we'll be looking at, right? So you can see here, let me change my listen to a pencil. So you can see here that at this block, we have a connective here, all right? And then we have this portion of the equation and that portion of the equation, right? So what do we seek to achieve here? We are saying that you have to split all this, okay, into further literals. And how do you do that? So with this, you break it down. So we take this portion first, then you further break this one down. So you see that comes here. Now I will further explain to you this. Okay, this you note on that. So the line by line approach is what you note down. Okay, so this is a typical example of a truth tree that has been presented to us. So all we are trying to say is that you have to break it down till you get to the literal. So you can see that at the literal level, there are certain things you also have to adhere to as far as the decomposition rules are concerned. So we're saying that when you have a negation like this, for instance, all right, and then we have this, what happens is that this is negated. This is also not negated. The two, all right, will be seen as presenting us with a zero effect. So meaning that at the end of the day, this will cancel out. Is what we're trying to say. If this is negative, in other words, we are canceling out this. So since it cancels out, all right, it means that this portion of the branch has a dead end. This is what we are trying to avoid. So in a tree, when we come across a situation like this, it means that we have reached a dead end, especially for that of P. So here is a dead end for P. Now, the same thing can be seen here. You realize that at this portion, all right, there's a dead end. All right, so these two, okay, have also reached their dead end. So we say that a branch or a tree is opened when its literals do not cancel out. Okay, so if it is closed, then it means that the literals have actually basically canceled out. In a case where we realize that maybe Q, okay, does not cancel out, that means that that portion of the branch is still opened. All right, so we say that even though the other portion is closed, this particular branch is still open. Right. So let's go further. You will soon appreciate what I want to carry on. Okay. Sorry, let me raise all. Okay. So we are saying that there are rules in every engagement. We are saying that the root is labeled with the formula that we are testing together with a truth value. You realize that at the root, it looks compounded. However, they all have their truth values. And at each step, we decompose the current formula, passing from information about its true value to a resulting information about its immediate sub-formula. And never in the opposite direction. That's why we're saying that when you have a literal, all right, appearing and they cancel out, it ceases to be a fruitful branch, right? The information is supplied by the truth table, whatever connective that is being decomposed at that point. So we realize that the decomposition, anytime we come across a connective, break them down, right? So we further go on to the rules and so that we get definite information about the immediate sub-formula. And we put it on every branch below the node. All right. One way of not forgetting this is by writing it down immediately before any further division or dividing take place. So when we get a disjunctive information about the immediate subformula, we divide our branch into two. So you'll come to understand this later. So example is this. These are the rules we are referring to. We are saying that at this point, this is at the top of this is the only root we have. You can see that we have a connective here. Now, when you write down the root, you indicate the connective and then right beside it the decomposition. All right, this is how we present the case. So you can see that with this, all right, we have a branch indicating the P and then the Q. All right, we did not break them like this. But when we come to this, now the branch occurs because we are trying to say that this negation is going to change the interface. So once this is coming in, it presents an opposite reaction. All right. So we're trying to say that the previous one here, it looked positive. In other words, they are all of the same value. Hence, that is why they are all in a linear form. But when we come here, it is going to give us, instead of it being linear, when we throw in the negation is going to make it happen or give it an opposite reaction. All right. So that's what we have here. So we realize that this branches off, okay, with the negations in there. You get it? Then alongside, you have to indicate the negation and then the connective. All right. So this is connective. Then this sign, the D, means decomposition. All right. So this is the first rule. This is the second rule. Okay. Let me change this to a pencil because everything's writing. So this is the first rule, and this is the second rule. Now we go to a third rule. Now with the third rule, we are saying that we have a wedge, right? We have a wedge. So this is the wedge. We are saying that this, okay, this wedge ordinarily should have made it split. But since there's a negation, all right, now it presents a linear case. I get it. So you come down. When we come down here, we realize that this ordinarily, because of this wedge, it presents as with a dividing literal. Okay, one goes in this direction, one goes in the other direction. Okay, but the moment a negation occurs, all right, it means that it now tends to the opposite, all right, which is this. You can see that a negation has occurred. So once a negation occurs, now it changes this double to a single line. This is a rule. I didn't create this. It's a rule you need to adhere to. All right, these are tree-related rules that you need to adhere to so as to enable you decompose efficiently. Right. So now at this point, we realize that since this has been thrown in, now it changes the branching, right, into a single branch. All right. So we negate both. And then this is the conclusion. We say that a negated wedge in a decomposition. All right. So this is the rule. Right. Okay. So we have some examples to play with. Okay. So that you can understand it and be able to follow through when you are doing your work. So at this point, this is the given set. Okay, this is the given set. We are saying that we start off by looking at the connectives, all right? And then also appreciating line by line, whatever we need to do. So we can see here that we have one, okay, forming part of this, the roots, all right? This is the second line. You can see that already this second line is a literal, meaning that it cannot further be broken down. So you ignore it, okay? Then our attention will be brought to this that has a literal, all right? Then further be broken down. Excuse me, somebody is calling. Hello? Good afternoon. No, what is happening? What problem is that? Let's look at this next week because I'm in the middle of a meeting now. Okay. All right. No. Okay, sorry, I had a call. All right. So as I was saying, I said this, okay, actually presents the case. With this, it has ended because it's just a literal. That is the main aim of the composition, for us to get to literal. And already we have this there. So it means no attention will be looked at that. Now we go back to our first point. What do? We, as you can see, we'll further break this down. So we would rewrite it in this format. So say 1, A, okay. I'm just rewriting it, okay. A, 2, C. Now, what do we do here? We would continue the line by presenting it with the third line. So the third line will be this, okay? So we'll put down A, okay? And then whilst we are writing this, beside it, we would note the line. So this is the line, okay? We'll note the line that we worked on. So line 1, okay? Then we would present the connective that was involved. So the connective that was involved is this connective. Then we would indicate the D. So we can say decomposition, all right? Decomposition, or you can just write there D, all right? Now, you realize that we are still not done. We'll have to still look at the next literal. So we will say line 4. In line 4, we present this one, all right? And then what do? We will indicate the line in which we worked on, we operated on, right? So we still operated on line 1. Then what was there? What was its effect? We realized that it was a decomposition. So we still bring up this, all right? And then indicate, you can just put here a D, okay? So at this point, what is happening? It's obvious that this is a literal. So this A, there is no negation to it. There's no negation to it. Even though there's a negation, it doesn't affect this because they are all negated. Hence, we have what? A complete open tree. or another we can say a completed open tree. Okay, so in an open tree, and we can also say a complete open branch. Complete open branch. So it means that this, even though it looks like the literals are there, it can still be worked on, meaning that it is not closed. That's the simple meaning of this. So this is what this tree is referring to. Okay. So we have successfully decomposed and given the verdict that it is a complete open tree, completed open branch. All right. Good. So if you have any questions, you ask me. If you understand it, thank God. We would move to the second one. Okay. So with the second equation, we can see that it's quite lengthy. We have, what do we call it? We have 3 steps, all right? We have this, we have that, and we have this, okay? So this is the given set. This is the given set. This is the beginning of the set you have been given to solve. Now, what do we do? To start off, we need to identify the literals in here, what we are going to look at and what we are going to decompose. So obviously, this is a literal. It can't further be broken down. So our attention will just move out of it. Then we will rewrite them here. Okay. So let me put down right here. Seeing 1, A, B, 2, B, 3, neg A, wedge, neg C. Okay. So at this point, we would look at A first, all right? Okay, so we will present the 4th line, which is A. Okay, so once we write the A, make sure that you indicate what? The line. So the number, the line which you actually worked on. So line 1. Okay, then you indicate the decomposition. So the connective that was involved there is what? It's this. So you present it, then you put there your decomposition. Okay, so we move on to the next. When we come here, we have what? 5. Right? This. Now this. So put down this. Then remember to put in the line. So we are still on line 1. Then we put in the connective, then our D. Okay. Now the seed line, there's a trick here. So watch this. Realize that we are now done with this. So you would mark this as done. Once you mark it, you mark it as done. Right? So let this check mark appear. Now, this, we did not look at this. Now we move on to the next. You can see that this presents us with what? A wedge. So since we have a wedge, it means that we need to split. Right? So this will have a split. Now we'll look at this separately. So we have what? A, neg, right? Then this will have C negative. All right. So now at this point, we have successfully broken this down. But don't forget to put down what you worked on. This was worked on what, line 3. So 3, then because the connective there is a wedge, put a wedge, then D. All right. So at this point, what happens? Let's look at the literals. We have a negative here. Okay. So let's take A for instance. So A, okay, you can see that here there's negative A and we have positive A. So obviously it will cancel out. Since they are canceling out, it means that this branch can no longer be resourceful. In other words, it has weeded out. Okay, that part of the branch is closed. Let's look at C. When I look at C, this is a negative, and as opposed to a positive. So these two will also rule out, cancel out, which means that we have a closed tree. At this point, the verdict is we have what? A closed tree. That's the verdict given to this. So meaning that we have a closed tree for this whole tree. All right. How interesting was this? We can see that the most interesting part of it is being able to identify the line in which you are operating in. All right. So you indicate them there with a connective. All right. So this is line 3. So we're operating at line 6, but our activity was on what? Line 3, right? So at the end of the day, this is what we have actually demonstrated. And the verdict is that this is a closed tree. Any questions so far? Yeah, there will not be questions. But if the questions come up, please feel free to ask me, okay? All right. Now, I have some assignment for you. Kindly do this and send it to me. All right, you know my email. Okay, send it to Bedao at iCloud. All right, iCloud.com. You guys already have my email. All right, so Victor Bedao, so Bedao at iCloud.com. When you are done with it, you can send it to me to have a look at it. All right. Okay, so play with this and let's see how it goes. Write them out. It will be interesting to write them out. You can use, if you are using a computer to do this, you will struggle. So just write them out for me. Okay, and give me and pass your final verdicts. Let me see whether you really understood this concept. Okay, so now this is where we come to. This brings us to the end of this lecture. If you have any questions whatsoever, kindly feel free to ask me, all right, or send me an email. Thank you so much for having me. I appreciate all of you, and I wish you all the best in your exams. Okay? Okay then. Bye.